Morning students, welcome back to our online classes. So today we will discuss the data representation, that is we will revise the concepts of data representation. I hope you all know that there is a assignment test for you on 24th of this month. You all know that. So for your test in computer science you have data representation chapter. So we will revise the concepts of data representation for your test. So in data representation we basically study about number systems. See, what is a number system? Number system is a way of representing the numbers, or it is a naming the number system. We call it as a number system. In number system we have two types of number system, that is non-positional number system and positional number system. Non-positional number system does not have any specific positional value. The example for non-positional number system is Roman number system. And next we studied about positional number system. In positional number system it has a specific positional value. Each value depends on its position. So in positional number system we have four different types of number system. One is decimal number system, second is binary number system, third one is octal number system, and fourth one is hexadecimal number system. In decimal number system we have digits from 0 to 9. We have digits from 0 to 9, that is total 10 digits, and the base of this number system is 10. The base of decimal number system is 10. What is the base? Base is the total number of digits present in number system. We call it as base. It is also called as radix. Base or radix. Base, another name for base is radix. Base means the total number of digits present in any number. We call it as base. The base of decimal number system is 10. Next, binary number system. In binary number system there is total 2 digits, that is 0 and 1. We have only 2 digits in binary number system, that is 0 and 1. Hence the base of this number system is 2. Next, octal number system. In octal number system we have total 8 digits, that is 0 to 7. So all the values will be between this 0 and 7. Hence the base of this octal number system is 8. See, base is 8, the digits are from 0 to 7, total 8 digits. Next, hexadecimal number system. Hexadecimal number system has the values or digits from, the range is from 0 to 9 and A to F. 0 to 9 digits and alphabets from A to F. A stands for 10, B is 11, C is 12, D is 13, E is 14 and F is 15. Hence the base of this number system is 16. So you should know this base values for your next conversions or any problems. What is the base of this decimal number is? Decimal number system base is 10, binary number system is 2, octal number system base is 8, hexadecimal number system is base is 16. See, in digital computers all the values will be stored in zeros and ones. So that zeros we call it as a binary digits. Bit, it is also called as a bit, and bit is an expansion of binary digit. Next we will see the number system conversions. Okay, now we will see the number system conversion. In that first one is decimal to binary conversion. So while converting from decimal to binary, the question may be like this: convert 50 to base 10. See, you should represent the base value because it represents which number system it belongs. So I have mentioned as base 10, so hence it is a decimal number system. Now this should be converted to binary system. So while converting from decimal to binary, what you should do? You should divide the given number by the base value, the next new base value, that is 2. So how I will divide? So take, this is the given number. Now divide this number by 2. So 2 2s are 4. So I am dividing the 5. 2 2s are 4. What is remaining? 1 will be left out. So it will become 1 2 is 12. So now 2 6 are 12. What is remainder? Remainder is 0. Again divided by 2. 2 1s are 2. 2 3s are 6. The remainder is 0. Next 2 6 are 12. The remainder is 1. Next, 2 3s are 6, the remainder is 0. Again divided by 2. 2 1s are 2, the remainder is 1. Now 1 cannot be divided by 2, so I will stop this process and now write the values, digits from bottom to top. That is 1 1 0 1 double 0. So in this manner 1 1 0 1 0 0 and its base value is 2. Now what is the binary equivalent value for 52? That is 110100. So you should represent the base value. So binary value, the base value for binary is 2. Now this is the binary equivalent value for decimal value 52. Next we will see one more problem. Okay. Next we will see the fractional part. It has both integer part and fractional part, that is 125.05. When we have a fractional part, both integer and fractional part, you should take separate as integer part as separate and fractional part as separate. Afterwards you should divide this integer part by 2 and the fractional part you should multiply it by 2. Now take integer part as separate. See what is integer part? Integer part is 125. Now this is integer part. Now you need to divide this integer part by 2. Now what is the number? Number is 125. Divide this number by 2. Now 2 6s are 12 and 2 2s are 4. The remainder is 1. Again divided by 2. 2 3s are 6. 2 1s are 2. The remainder will be 0. Next, 2 1s are 2. Now 1 is left out here. So it will become 11. Now 2 5s are 10. The remainder is 1. Again divided by 2. 2 7s are 14. The remainder is 1. Next, 2 3s are 6. The remainder is 1. Next, 2 1s are 2. The remainder is 1. Now 1 cannot be divided by 2. Hence I will stop this process. Now write the values from bottom to top. What is the binary value? That is 1 1 1 1. So totally we have 5 ones. 0 1 and the base is 2. Now this is for only for integer part. Next take the fractional part as separate. What is the fractional part? So here fractional part is, it will become 0.05. So I have taken 125 as separate. Now it will become 0.05. Now what you should do? You should multiply this fractional part by 2. So now multiply this by 2. 2 5s are 10. So it will be 0 and 1 will be carried. Next, 2 into 0 is 0. You have 1. So it will be 1. And next, there is no carry. You should write 0.10. So that will become 0.10. Now you should note down the integer part. Now note down the integer part. Next, take this value 0.10. Only you should take only the fractional part. Whatever it may be, here it may be 1 or 0. You should not consider this. You should take only the fractional part. Next, that will be 0.10. Multiply this by 2. 2 into 0 is 0. 2 ones are 2. Next, you don't have any carry, so I will be writing 0. So now note down this value, that is integer part. Again consider the fractional part, that is 0.20 multiplied by 2. 2 into 0 is again 0. 2 2s are 4. 2 2s are 4. There is no carry, so it will be 0.40. Now again consider this integer part. Again take the fractional part. 0.40 multiplied by 2. 2 into 0 is 0. 2 4s are 8. No carry. So So it will become 0. See, in this situation, you have, it will be recurring. The values will be recurring. Till where you need to perform this operation means till you get the fractional part as 0. Sometimes, in some cases, you will get fractional part as 0. That like that 1.00 or 0.00 you will get like this. That is fractional part will become 0. But in this problem, you will not get fractional part as 0 as though you continue this process. So it will be recurring. So in this situation, you need to take only 3 or 4 possible ways. That is 0, 0, 0. Now I will take only 3 values. That is 0, 0, 0. That is 0.00. You should take 0.000. Means you in this process you should consider the values from top to bottom. Now it is this one. Now combine these two, integer part and fractional part as equal one single value. That is, now what is the integer value? What is the binary value for integer part? That is 1, 1, 1, 1, 1, 0, 1 and 0.000 and the base is 2. Now this is the binary equivalent value for this 125.05. See, when you have both integer part and fractional part, you should consider the integer part as separate and fractional part as separate. For integer part, you need to divide the given number by 2, and for fractional part, you need to multiply it by 2. You should perform this operation till you get the fractional value as 0. Sometimes if you not get fractional value as 0 and it will be recurring, in that case you should take only 3 possible ways. That is, I have taken only 3 values. So this is the end of this problem. Now we will see one more conversion. Okay. Now we will discuss one more conversion, that is decimal to octal conversion. So while converting from decimal to octal, you need to consider this value and divide the given number by 8. See, in binary to decimal to binary conversion, we were dividing it by 2. Here from decimal to octal, you need to divide this number by 8. So take this number 148. Now divide this by 8. Why we are dividing it by 8 means the base value of octal is 8. So you should divide it by 8. Now 8 ones are 8. 8 ones are 8. What is left out here? So 8 minus 14 is, you will get 6 as the remaining value. Now it will become 68. So 8 8s are 64. The left out value is 4. Next, 8 1s are 8. 8 2s are 16. What is left out? So it will be, remainder is 2. Now your 2 cannot be divided by 8. So now you stop this process here and take the values from bottom to top. That is 2, 2, 4 and the base is 8. So base of this octal number is 8. See, while converting from decimal to octal, in octal conversion you will get the values from in this value. In binary values you got only zeros and ones as a result, but in octal you will get the range is from, the octal range is from 0 to 7. So you will get the values between this range, that is 0 to 7 only you will get. You will not get octal, like you will not get 8, 9, 10 digits, you will get only 0 to 7. So now what is the binary octal equivalent value for this 148 is 224 base 8. Now we will see one fractional part example. Now take this example, it has both integer part and fractional part. So we are taking the real value, that is 65.15. Now the same procedure you need to follow. What procedure you followed in decimal fraction to binary, the same procedure, but here you need to divide it by 8 and multiply it by 8. Now take the integer part, take separate integer part and fractional part. Integer part is 65. Now what you should do, you should divide this integer part value by 8. Now 8 8s are 64, the remainder will be 1. Next, divided by 8, 8 ones are 8, the remainder is 0. Now you got 101 as the answer. So even 101 is in the range of 0 to 7. The base of this number system is octal is 8. So you always remember the base values. If you neglect this base value, so that will not identify which number system it belongs. So always you should write the base values. Now 101 is a octal equivalent value for 65. Next, take the fractional part as separate. In fractional part you have, so fractional part is 0.15. So I have taken 65 as separate. The remaining thing is 0.15. It is a fractional part. Now what you should do? You should multiply this fractional part by 8. So now 8 5s are 40. So the carry is 4. Now 8 1s are 8. 8 plus 4 is 12. So I will write 2 and next 1 will be carried. 1 will be carried, that I will write 1.20. Now note down this integer part. Next consider only the fractional part, that is 0.20 and multiply it by 2. Next 8 into 0 is 0. 8 2s are 16. So 16 I will write 6 and 1 will be carried. 1 will be carried to the next position, that is 1.60. Again note down this integer part. Next consider only the fractional part, that is 0.60 multiplied by 8. So 8 into 0 is 0. 8 6 are 48. So I will write 8 and 4 as the carry. So that will be 4.80. And note down this integer value. Next consider only the fractional part, 0.80 multiplied by 8. So 8 into 0 is 0. 8 8s are 64. So 4 will be written and 6 will be carried to the next position. So now it is 6.40. Now take down the integer part. So in this situation also, if you continue this process also, you will not get the fractional part as 0. So I will stop here only. I will take only the 3 or 4 values. Now that is from top to bottom. Now what is this? 1 1 1 1 1 4 6. That is 0. So that is only, this is fractional value, right? So you should take 0.1146. The base is 8. Now combine this both integer part and fractional part as one number. That is, what is the number? I will write here 101. Next fractional value is 1146. The base is 8. So this is the octal equivalent value for this 65. So this is how we perform the decimal to binary conversion and decimal to octal conversion. Next we will see decimal to hexadecimal conversion. Okay. Now we will discuss decimal to hexadecimal conversion. The base of hexadecimal number system is 60. So you should divide the given number by 60. Now this is the 243 is a decimal number. Now you need to convert this to hexadecimal. Divide this by 16. Take the value, that is 243. Now divide it by 60. So 16 ones are 60. 16. So 16 twos are 32. You cannot divide. So 16 ones are 16. What will be left out? 24 minus 16 will be 8. So it will become 83. Now 83 means 16 5s are 80. So 80 means 3 is left out. The remaining value is 3. Next 15 cannot be divided by 16. So you should stop this process here and take the values in this manner. So that is 15 and 3. So 15, 3. Now in the hexadecimal number system, the range is from 0 to 9 and A to F. So if you get 0 to 9 digits, you can directly write that were digits. If you get after 10, after 9, that is 10, 11, 12, 13, 14 and 15, you cannot represent it as it is. You need to write the alphabetical value, that is the what is the representation of this digit you need to write. What it represents? 15 represents F. 15 represents F and 3 as it is. So the base value is 16. Now F3 is the hexadecimal equivalent value for your decimal value 243. See, in hexadecimal number system, if you get the digits after 9, that is 10, 11, 12, 13, you need to represent its equivalent alphabetical value, that starts from A to F. Now what is the value of 10? 10 represents A, 11 represents B, 12 represents C, 13 is D, 14 is E, 15 is F. So if you get any of these 5 digits, 5 values, you need to represent its equivalent alphabetical value, that is A, B, C, D, E. Now 15 represents F value. So you need to write, in place of 15 you need to write F and 3 as it is. Now and mention the base value as 16. So it shows the hexadecimal value for your decimal value. Now we will see one more example. Okay, now we will see one more problem, that is convert 518 to hexadecimal value. So same procedure, you need to divide this by 518 by 60. Now 16 3s are 48. So 16 3s are 48. What is left out? You will be left out with 3. Thus that is 51 minus 48 will be 3. So it will become 38. Now 16 3s are 48. 38 will be left out. Now 16 2s are 32. 38 minus 32 will be, the remaining value is 6. Next, again divided by 2. 16 2s are 32. The remainder value is 0. Now 2 cannot be divided by 60. Stop the process and write the value digits from bottom to top. That is 2, 0, 6. The base value is 16. Now 206 is the hexadecimal equivalent value for the decimal value 580. Now this is the end of decimal to other number system conversion. In decimal to other number system we had, so the base, I'll write base values, decimal to binary conversion we have seen, and decimal to octal conversion we have seen, and decimal to hexadecimal number system we have seen. So in this process, whatever may be the number, when converting from decimal to binary, octal and hexadecimal value, you need to divide it by the new base value or the destination value. Now destination value is 2 because we are converting from decimal to binary, so the destination value is 2. Now you need to divide it by 2. Here also you need to divide it by 8, and here you need to divide it by 16. So keep this in your mind. While converting from decimal to any other number system, you need to divide the number by its new base value. So this is the decimal to other number system conversion. Now we will see any other number system to decimal conversion. Now we will discuss binary number system to decimal number system, means any other number system to decimal conversion. It includes both binary to decimal conversion, octal to decimal conversion, and hexadecimal to decimal conversion. So in this conversion, you need to multiply it by its source value, source base value means by its own base value. Now we have a binary value. Binary to decimal means the base of this binary is 2. And octal to hexadecimal, you need to multiply the given digits by 8, and while converting from hexadecimal to decimal, you need to multiply this by 60. So you need to multiply this by the base value 60. This is the process, and while converting from decimal to, you have already seen. Now we are discussing about from any other number system to decimal conversion. Now we will see binary to decimal conversion. So here we have a problem, convert 10011, that is a binary digits. This should be converted to your decimal value. So in your test or exam they will ask like this. So they will not directly ask convert binary to decimal. They will not ask like this. they'll ask convert, they'll give you the digits and its base value and to its equivalent base value. That is, it means you need to convert this binary value to decimal value. You need to understand from which number system we are converting to which number system. You need to understand and try to solve the problems. Now take this value 1 0 0 1 1. Now what you should do, you should multiply this each and every digit by 2. That is from, now I will write from 1 into, here we don't have any real value, that is fractional value, we have only integer part. Now in this situation I will do this, multiply this by 2. Now 1 into 2. Now I am multiplying this digit by 2 and plus 0 into 2. Again we have 0 plus 0 into 2. Next we have 1, that is plus 1 into 2. Again we have 1, that will be 1 into 2. Since we don't have any fractional values, the positional value starts from your right to left. That is, this in this situation here it starts from right to left. So you need to mention the positional values. Always the positional value starts from 0. Now 1, 2, 3 and 4. Only for the base values you need to write the positional values. Now expand these terms. 1 into 2 power 4 is, that is 2 power 4 means 2 should be written 4 times. That is 2 into 2 into 2. That is 2 into 2 2s are 4, 4 2s are 8, 8 2s are 16. So 2 power 4 is 16. Next 0 into 2 cube, that is 2 into 2 into 2. 2 2s are 4, 4 2s are 8. So 2 cube is 8. Next plus 0 into 2 into 2, that is 2 square is 4 plus 1 into 2 power 1 is 2 plus 1 into 2 power 0 is 1. Anything to the power 0 will be 1. Next multiply this. 16 into 1 is 16 plus 8 into 0 is 0 plus 4 into 0 is 4 plus 2 into 1 is 2 plus 1 into 1 is 1. Now add all these terms. 16 plus 0 is 16. Again you have 0, so it will be 16. 16 plus 2 is 18. 18 plus 1 is 19. So the base value is 10. Since we are converting from binary to decimal, I am representing the base value as 10. It represents, this is the decimal value. Now we will see another. So now take another problem. Convert 1110.101. Means it has both integer part and fractional part. When you have this type of problem, you need to multiply again. You need to multiply it by 2. Now 1110.101. Now take 1110.101. Now this is the integer part. Now I will start from this side only. That is 1 into 2 plus again 1 into 2 plus 1 into 2 plus 0 into 2. Now this is the end of integer parts. Now first you write down the positional values for integer part, that is from right to left. So 0, 1, 2, 3. Next you have a fractional part, that is also you need to join by adding the plus sign. Now you have 1 into 2 plus 0 into 2 plus 1 into 2. Now after your decimal point, after the decimal point, the positional values will start from left to right. Means you need to represent the positional values from in this direction. That is, you need to start from here. That's always after the decimal values, the positional values will start from negative sign. That means it is 0. After the 0 it will be -1. Next it will be -2. Next this is -3. Now expand the terms. 1 into 2 power cube, that is 2 into 2 into 2, that is 8, plus 1 into 2 power 2 is 4, plus 1 into 2 power 1 is 2, again 0 into 2 power 0 is 1, anything to the power of 0 will be 1. Next 1 into 2 power minus 1, see always 2 power minus 1 can be written as 1 divided by 2 power 1. So 2 power minus 1 can be written as 1 divided by 2 power 1, that is 1 by 2. 1 by 2 is 0.5. 1 by 2 is 0.5. So I will directly write 0.5. 2 power minus 1 value is 0.5 plus 0 into 2 power minus 2. So 2 power minus 2 can be written as 1 divided by 2 power 2, that is 1 divided by 4. See 1 divided by 4 is 0.25. 0.25. Now 0.25. 2 power minus 2 is 0.25 plus 1 into 2 power minus 3. See 2 power minus 3 can be written as 1 divided by 2 cube. 1 divided by 2 cube is 8. So that will be 0.125. So 2 power minus 3 value is 0.125. 0.125. Next, multiply the terms. 8 into 1 is 8 plus 4 into 1 is 4 plus 2 into 1 is 2 plus 0 into 1 is 0 plus 1 into 0.5 is 0.5 plus 0 into 0.25 is 0 plus 1 into 0.125 is 0.125. Now add all these terms, that is 8 plus 4 plus 2, that will be 8 plus 4 is 12, 12 plus 2 is 16, 16 plus 0.5 and 0.125, you get 14.625, the base is 10. Now this is the decimal equivalent value for the given binary value. So this is how you will convert when you have a binary value and you should convert it into decimal value. If you have any fractional value, after the fractional value or after the decimal point, the positional values will start from negative sign, that will be -1, -2, -3 and so on. Before the decimal point, the values will be, that is positive positional powers of your positional value. See, always try to remember this thing and try to mention the positional values correctly and try to expand the terms. Use your calculators for performing these operations. Next we will see one more conversion. Now next conversion is octal to decimal conversion. While converting from octal to decimal, you need to multiply the given number by 8. Now this is the number, octal number. You need to multiply this number by 8. Now take 147. Now multiply this given digits by 8. Now take first digit, that is 1 into 8 plus 4 into 8 plus 7 into 8. Now write the positional values before, because you don't have any decimal point here, you have only integer part, hence you need to start the positional values. Powers you should write from right to left, means right to left, that is 0, 1, 2. Now 1 into 8 into 8 is 8, 8 square is nothing but 8 into 8, 8 8s are 64 plus 4 into 8 power 1 is 8 plus 7 into 8 power 0 is 1. Anything to the power 0 is always 1. Next 64 into 1 is 64 plus 8 fours are 32 plus 7 into 1 is 7. Now add all these terms, that is that is 64 plus 32 plus 7, so it will be 103 and the base value is 10 because we are converting from octal to decimal. Now it represents the decimal value. Now we will see when we have a fractional part and decimal point. Okay, now take next problem. Second problem, that is convert 256.34, that is in octal number you should convert to decimal number. When you have the decimal point, see as I told, after the decimal point the powers will start from negative sign, that is -1, -2, -3, and before your decimal point powers will be in positive. Now take this value, that is 256.34. Now multiply each and every digit by 8. Now 2 into 8 plus you have 5 into 8 plus you have 6 here, 6 into 8. Now this is the end of integer part. So first you write down for integer part, that is powers start from 0, 1, 2. Next you have after the decimal point you have 3 and 4. For this you have 3 into 8 plus 4 into 8. See after the decimal point you should write the positional values in the negative sign. That is for 3 and 4. For 3 into 8. For this you need to mention it as -1 and for this you need to mention it as -2. Now expand these terms. 2 into 8 power 2, that is 8 into 8 is 64, 8 8s are 64 plus 5 into 8 power 1 is 8 plus 6 into 8 power 0 is 1. See 8 power 0, anything to the power 0 is always 1 plus 3 into 8 power -1, that is 8 power -1 can be written as 1 divided by 8 plus 4 into 8 power -2. 8 power -2 can be written as 1 divided by 8 power 2. Next 64, multiply 64 and 2, that is 2 4s are 8, 2 6 are 12. So 64 into 2 is 128 plus 8 5s are 40 plus 6 into 1 is 6 plus now 3 into 1 divided by 8. 1 divided by 8, 8 power -1 can be written as 1 by 8. Now the value of 1 by 8 is 0.125. So that is 0.125 plus 4 into 1 divided by 8 cube, that is it has 8 power -2. 8 power -2 can be written as 1 by 8 power 2. 8 power 2 is 1 divided by 64. The value of 1 divided by 8 power 2 is 0.015. 0.015. Again 128 plus 40 plus 6 plus 3 into 0.125. Multiply these two terms, you will get 0.375. Next you have 4 into 0.015, that will be 0.06. So take your calculator and multiply these terms, you will get 0.375 plus 0.06. Now add all these terms, that is 128 plus 40 plus 6 plus 0.375 plus 0.06, you will get value 174.435. After adding all these values, you will get 174.435 and the base is 10. This is the decimal equivalent value for 256.34, that is your octal number. Now another conversion, that is hexadecimal to decimal conversion. Here we have A to B, that is a hexa number system. You need to convert to decimal number system. What you should do, you should multiply these numbers, digits by 60. Now take A to B, that is in hexadecimal. Now consider the first digit, that is A into 16 plus we have 2 into 16 plus you have B into 16. Here we have only integer part, we don't have any decimal points here. So in this situation you should start the positioning the values from right to left. This is from right to left, 0, 1 and 2. Now what is the value of A? See, as I told, hexadecimal number system has the range from 0 to 9. After the 9, if you want to represent 10, see, your A represents the value 10, B is for 11, C is 12, D is 13, E is 14, F is 15. Now we have A. The value of A is 10. The value of A is 10 into 16 into 16. That will be 16 into 16 is 256 plus 2 into 16 power 1 is 16 plus what is the value of B? Value of B is 11. See, value of B is 11 into 16 power 0 is 1. Now multiply these two terms. 10 into 256, that is 2560 plus 16 into 2. 16 2s are 32 plus 11 into 1 is 11. Now add all these terms, that is you will get, after adding this you will get 2603 and its base is 10. Now add 2560 plus 32 plus 11, you will get the value 2603 and the base value is 10. Since we are converting from hexadecimal to decimal, the base value of this result is 10. Next we will see one more example. Okay, next you have, another problem is CAFE 0.05. Now C into 16. Multiply each and every number value by 16. C into 16 plus A into 16 plus F into 16 plus E into 16. Now this is your integer part, right? So you should start positioning the values from right to left. 0, 1, 2, 3. See, after this decimal point you have 0, 5. You should write 0 into 16 plus 5 into 16 and the positioning is starts from -1, -2. Okay. Now the value of C. What is the value of C? A is 10, B is 11, C is 12 into 16 cube. That is 16 into 16 into 16 is 4096 plus what is the value of A? Value of A is 10 into 16 power 2. 16 into 16 is 256 plus F is 15 into 16 power 1 is 16 power 1 is 16 plus E is, value of E is 14 into 16 power 0 is 1 plus 0 into 16 power -1 can be written as 1 divided by 16 plus 5 into 16 power minus 2 can be written as 1 divided by 16 power 2. Now multiply these two terms, that is 12 into 4096. The value is 49152. 49152 plus 256 into 10 is 2560 plus 15 into 16. What is the value of 15 into 16 is, your value is 240 plus 14 into 1 is 14 plus 0 into 1 by 16. 1 by 16 value is 0.0625 plus 5 into 1 divided by 16 square. 1 divided by 16 square is 0.0039. Next, again 4. So again I will write the number as it is, 49152 plus 2560 plus 240 plus 14 plus, now 0 into 0.0625 is 0 only, plus 5 into 0.0039. 5 into 0.0039 is 0.0195. Now add all these terms, you will get the value 51, that is 966. 51966.019 and the base is 10. So after adding all these terms, you will get 51966.019. The base value is 10. So this is the end of any other number system to decimal number system. Here we have seen binary to decimal number system, octal to decimal number system, and hexadecimal to decimal number system. Okay. Now we will see one more conversion, that is binary to octal conversion and octal to binary, that is vice versa. Now we will take an example 1101111. So this is your binary value. Now you need to convert this binary value to octal. So in this process, what you need to do, you need to divide the given digits into group of 3 bits. While converting from binary to octal, you need to divide the given digits into group of 3 bits. That is starting from right to left. That is from right to left. So here I will divide. I will take this number as it is 1 1 0 1 1 0 1 1. Now start grouping the digits from this way. That is from right to left. 3 groups means 1 2 3. This is one group. 1 2 3 is another group. Now you have 1 and 1. If you want to make it as a group of 3 bits, you can add 0 to your left side. That is your MSB. You can add 0 to the MSB to make it as a group of 3 bits. So here we don't have any decimal point, hence we can add the zeros towards your left side. Now write the octal equivalent value for this binary value. What is 0 1 1? So I have told what is 0 1. You have studied about the code, that is 8421 code. That is your BCD code you have seen. Now what is 0 1 1? So here we have only binary to octal conversion. Here we use only 3 positional values, that is from 2 power 0, 2 power 1 and 2 power 2. Hence we take only 3 digits. Now write what is 0 1 1. 0 1 1 is, so this is the binary digit 0 1 1. The octal equivalent value for 0 1 1 is 2 plus 1 is 3. This is in the position 2 and 1. So 2 plus 1 is 3. Now 0 1 1 is 3. Next we have 0 1 1. The octal equivalent value for 011 is again 3. Again we have 011, so I will write 3. Now combine these 3 digits into single number and write the base value. That is, we have a binary value and we are converting it into octal value. When converting from binary to octal conversion, you need to group the digits or bits into group of 3 bits, and if you want to add zeros to make it into a group of 3 bits, you can add zeros to your left side, that is to your most significant bit. This is the MSB, you can add zeros to your MSB. And after dividing the group of 3 bits, you can write the octal equivalent value for this binary value. Here 011 is 3 and here 011 is again 3, 011 is again 3. And combine all 3 digits into a single value, that is 333, and the base is 8. Now we will see when we have a decimal point. Okay, now we have a decimal point here. Next problem is we have a decimal point. When we have a decimal point, you need to add zeros. If you want to add any zeros after the decimal point, you can add it to your towards your right side. Now I take 1, 0, 1, 0, 0.10. This is the given digits. Now group these digits divide the numbers into group of 3 bits. Now before your decimal point, I will start from this side. Before the decimal point, start dividing the number, that is 0, 1, 0. Means it is one group. Next we have only 1 and I should make it as a group of 3 bits. I will add zeros to your left side. That will become 0, 0, 1. Next is 0, 1, 0. After the decimal point, start dividing the numbers in this direction, that is from left to right. Now we have only 2 digits here. I can add 1 0 here towards your right side to make it into a group of 3 bits. Now it is one more part. These 3 is one more group and these 3 is one group and these 3 is one more group. Now what is 0 0 1? Again we will take 3 digits, that is 2 4 1. So now we have 0 0 1. 0 0 1 is, we have 4, 2 and 1. We have this code because in octal we have only 3 positional values, 3 digits. Now we have 4 to 1. What is this? That is 0 0 1. So where we have placed 1, it represents the value 1. 0 0 1 is 1. Again we have 0 1 0. 0 1 0 means it shows the value is 2. Next we have 1 0 0. The 1 0 0 value is 4. Now combine these 3 values, that is 1 24. The base is 8. So now here 1 2. Here we have a decimal point. So place decimal point here, and while combining also you should write a point, that is 12.4 and base is 8. This is the octal equivalent value for 1010.10. This is how we will convert conversion from binary to octal. While converting from binary to octal, you need to divide the bits into group of 3 bits and write the decimal equivalent values for these bits and combine the digits to get the final octal value. Next octal to binary. There we have studied binary to octal. Now this is a vice versa, that is octal to binary. So here what you need to do, you need to take each digits, take the binary values for each and every individual digits. Now I take the binary digit for 3. What is the binary digits for 3? That is 2 plus 1 is 3, that is 0 1 1. So if you can't remember this, I have already explained how to find out the binary value. You need to divide the given number by 2. That is 2 ones are 2, the remainder is 1. Again you cannot divide it by 1 cannot be divided by 2. So 1 1, that will be, before this you have 0, that is 0 1 1. So we can represent like this. Next, write the binary value for 4. What is the binary value for 4 is 1 0 0. 1 0 0 is the binary equivalent value for 4. Next you have 7. For 7, what is the binary equivalent value? 4 plus 3 plus 1, that will be 4 plus 2 plus 1, that is 1 1 1 1. Now we have taken the individual binary values for this octal values. Now combine all these binary digits, that is 0 1 1 1 0 0 1 and mention the base as 2. Thus this is the binary equivalent value for octal value 347. We have discussed about binary arithmetic. In that binary arithmetic we have studied about binary addition and binary subtraction. See, in binary addition we have 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 will become 2. See, 1 plus 1 will be 2, but in binary we cannot represent 2 directly. So what is the binary value of 2 is 1 0. So 1 0, in normally how we will write? First we will write only this value and this will be carried to the next higher position. In the same way, this is in the decimal number system. So when we have a binary number, the binary value of 2 is 1 0. So we will represent 0 here and 1 will be carried to the next higher order bit, that is with carry 1. That is 1 plus 1 is 0 with carry 1. Next we have discussed about binary subtraction. See, in binary subtraction 0 minus 0 is always 0, 1 minus 0 is 1, 1 minus 1 is 0, 0 minus 1. 1 cannot be subtracted from 0. So here what you need to do, you need to borrow 1 from the next higher order bit, that is 0 minus 1. So when you borrow it will become 2. 2 minus 1 will be 1 and that is you need to borrow 1 from the next higher order bit. So these are the rules you need to follow while adding binary values and while subtracting the binary digits. Next we have discussed about ones complement. See, what is ones complement? Ones complement is nothing but changing each 0 to 1 and changing each 1 to 0. If we have 1, you need to write it as, you need to change that to 0. If we have 0, you need to change that to 1. So I will give an example. See, suppose consider this as an example. Now this is really 1 0 1 1 0 1 1. This is in binary form. See, always all binary arithmetic, here it is also comes under binary arithmetic. Binary is nothing but 0 and 1s. All the operations will be performed on zeros and ones. So that's why I have taken this as an example. Now what you need to do, you need to change each 0 to 1 and each 1 to 0. Now we have, here we have 1. So what 1 should be changed to 0. Here we have 0, again 0 is changed to 1. 1 is there, 1 should be changed to 0. Again we have 1, this should be changed to 0. Again 0, it will become 1. We have 1, that is 0. 1 is again changed to 0 and 1 should be changed to 0. So this is how we perform ones complement. In ones complement, we need to change each 0 to 1 and each 1 to 0. Wherever we have 1, that should be changed to 0. Wherever we have 1, that should be changed to, that is ones complement. Now we will see, we have discussed about twos complement. Next we have discussed about twos complement. This also can be written as twos complement and this can be written as ones complement. See, what is twos complement means? First, before converting this to twos complement, you should take the ones complement of the given digits. After getting the ones complement, you need to add 1 to the least significant bit. that is your rightmost bit. What is the first bit you have? For that bit you need to add 1 to the least significant bit to get the 2's complement. See, consider this example. We will take same example 1 0 1 1 0 1 1. Now you need to convert this to 2's complement. You need to find out the 2's complemented value for this. Now what you should do, you should first find out the 1's complement. What is the 1's complement for 1 0 1 1 is, see, 1 is changing to 0 1 0 0 1 0 0 0. So this is 1's complement. See, after finding the 1's complement, you need to add 1 to this position. See, add this 1 to this position. So 0. Now add these two values. 0 plus 1 is 1. Here we have 0, again 0, 1, 0, 0, 1, 0. Now this is the 2's complemented form for this value. Now this is the 2's complemented form for this value. This is how we perform 1's complement and 2's complement. Next we will discuss. Now again we have discussed about subtraction using 1's complement. See, in subtraction using 1's complement, what you need to do, just I will tell the steps for doing the 1's complement subtraction. So here first you need to find out the binary equivalent value for the given numbers. First you need to take the binary values for given decimal number. Next find out which is the minuend and which is the subtrahend. After finding the subtrahend and minuend, next you need to take the 1's complement for subtrahend. Since we are using 1's complement subtraction, you need to take the 1's complement for your subtrahend. Whatever may be the number, that subtrahend you need to take the 1's complement. After finding the 1's complement, you need to add that to your minuend. See, after adding it to minuend, if you get a carry, you need to add that carry back to your LSB. And if you don't get carry, recomplement the given answer and attach a negative sign before the digits. That will give you the final answer. So these are the steps you need to follow while performing subtraction using 1's complement. Now you have a problem, that is subtract 6 from 9. 6 from 9 means 9 minus 6. So 9 minus 6. 6 from 9 means we are subtracting 6 from 9. 9 minus 6. Now first find out which is the minuend. Here the minuend is 9. Why minuend? What is minuend? From which number we are subtracting, that number we call it as minuend. Next find out which is the subtrahend. Here subtrahend is 6. Which number we are subtracting, that number is subtrahend, that is 6. Now find out the binary equivalent value for 9 and 6. How to find out the binary equivalent value? So I have already discussed. Divide the given number by 2. 2 4s are 8. The remainder is 1. Again divide this by 2. 2 2s are 4. The remainder is 0. Divide it by 2. 2 1s are 2. The remainder is 0. Now 1 0 0 1 is the equivalent value, binary equivalent value of 9. 1 0 0 1. Next, for 6 you need to find out the binary value. The same procedure. 2 2 3s are 6. The remainder is 0. Again 2 1s are 2. The remainder is 1. Now 1 1 0 1 1 1 1 0, and here we have 4 digits, here we have 3 digits, so you can add 1 0 to your left to make it equal. Now we have 0 1 1 0 is for 6, 1 0 0 1 is for 9. Now what you should do, you should take the 1's complement. 1's complement for your subtrahend. See, what is 1's complement of subtrahend? 1's complement of 6. 1's complement of your subtrahend is 6. See, I will take directly what is, this is the binary value, you need to find out the 1's complement. Now what is 1's complement? 0 should be changed to 1 and 1 should be changed to 0. Here we have 0, 0 is changed to 1, again 1 is changed to 0, 1 is changed to 0, 0 is changed to 1. This is the 1's complement of 6. 1's complement of 6 is 1001. Now what you should do? You need to add this 1's complement to the minuend. Here add minuend. So what is a minuend here is? Minuend is 1001. 1001 and the 1's complement subtrahend is 1's complement of 6. Subtrahend here is 6. So what is the 1's complement of 6? That is 1001. Now add these two values. That is 1 plus 1 is 0. So 1 plus 1 is 0 with carry 1. 1 plus 0 is 1 and 1 plus 0 is 1. 0 plus 0 is 0. Again 1 plus 1 is 0 and with carry 1. So you are getting a carry here. So this is the carry. So when you get a carry, you need to add this one carry back to your LSB. See, now I will add. Now you need to add this 0. 1 should be added to your least significant bit. 0 plus 1 is 1. Again we have 1, 0, 0. This is the write the binary value, binary base value. So this is the final answer you will get. So 0, 0, 1, 1 is a value result you are getting from your for the subtract 6 from 9. That is 3. So this is when we get a carry, we need to add this back to the LSB. See, suppose if you don't get carry here, there will be no carry. That time what you should do, you should take this as the final result. Take the 1's complement for this result and attach a negative sign. If you get a carry, you need to add back to the LSB. If you don't get carry, take the 1's complement of this result and add a negative sign. That will be the final answer. Now for this problem, this is the final answer 0011. This is 3. That is 9 minus 6 is subtraction using 2's complement. So in subtraction using 2's complement, what we need to do? First we need to find out which is the minuend and which is the subtrahend. After finding, take the binary values for minuend and subtrahend. And after binary values, you should take the 2's complement for subtrahend. See, after taking the 2's complement for your subtrahend, you need to add that to your minuend. Add minuend and subtrahend, 2's complement of subtrahend. After adding, if you get carry, ignore that carry, means leave that carry. If you don't get carry, recomplement that obtained result. Recomplement means take the 2's complement of the given obtained result. So that will give you the final answer. So now we will discuss one problem based on subtraction using 2's complement, that is subtract 9 from 6. Here subtract 9 from 6 in the sense 6 minus 9. 6 minus 9. Now find out which is the minuend and which is the subtrahend. Here which is the minuend? Minuend here is 6 because we are subtracting from 6. Next, find out the binary value of 6. So how to find out? Take 2 and divide it by 2. 2 3s are 6. The remainder is 0. Again divide it by 2. 2 1s are 2. The remainder is 1. Now 1 1 0. 1 1 0 is a binary equivalent value for 6. Next, take the subtrahend. Your subtrahend is 9 because we are subtracting 9. Now take the binary value of 9. The binary value of 9 is divided by 2. 2 4s are 8. The remainder is 1. Again divided by 2. 2 2s are 4. The remainder is 0. Divided by 2. 2 1s are 2. The remainder is 0. Now 1 0 0 1 is a binary equivalent value of 9. 1 0 0 1. Here we have only 3 digits, so you can add 0 to make it equal. Now take the 2's complement of subtrahend. Now 2's complement of subtrahend is 2's complement of subtrahend. Here subtrahend is 9. So how to find out 2's complement? First take the 1's complement, add 1 to the least significant bit. Now I am taking 1's complement, that is 0 1 1 0. Now I am adding 1 to this bit, that will be 0 plus 1 is 1 1 1 0. Now this is the 2's complement of 9. 0 1 1 is the 2's complement of 9. Next, after finding the 2's complement, what you should do? You should add this 2's complement to the minuend. Now take which is the minuend. Here minuend is, the minuend value is 0 1 1 0. Next, 2's complement of subtrahend. 2's complement of 9 is 0 1 1. This is the 2's complement. So 0 1 1. Now add these two values. 0 plus 1 is 1. 1 plus 1 is 0 with carry 1. Now we have 1 plus 1 plus 1. So in this case 1 plus 1 plus 1 is 3. So in decimal value 1 plus 1 plus 1 is 3. But 3 cannot be written as it is. The binary value of 3 is 1 1. So I will write only 1 here and 1 will be carried to the next higher position. Now 1 plus 0 is 1. Again 1 plus 0 is 1. Now see, here we did not get any carry. So what you should do? You should take the 2's complement of this obtained result. See how we can take the 2's complement. Again take the 1's complement. 0 0 1 0. Add 1 to this 1's complement. See, this is first 1's complement. Here 1's complement. Add 1. 0 plus 1 is 1. 1 0 0. Now this is the 2's complement of the obtained result. This is the 2's complement of the obtained result. Now what you should attach a negative sign before the digits and write the base value. So now this is the 0 minus 0 0 1 1 is the final result we obtained after doing this process. That means 6 minus 9 is always minus 3. 0 0 1 1 is 3 and we have a minus sign that represents minus 3. This is the final result. See, this is about subtraction using 1's complement and 2's complement. So this is the end of this data representation revision. If you want more problems, you can see the previous videos. In the previous videos I have already explained the more number of problems. This is only for revision. I have explained 1 or 2 problems. If you want more problems and if you want to see, you can see the previous videos and practice for your assignment test and do well. All the best. Thank you.